volts. Problem 2. How much energy does a 100-watt electric bulb consume in 2 hours? Over here, the given information is power and time, and we have to determine the energy. We know that energy equals power multiplied by time. Over here, time is in hours, so we have to convert it to seconds. Thus, we multiply 100 with 2, then convert that hour to seconds by multiplying it with 60 and again 60. That gives us 7,20,000 joules or 720 kilojoules. If you don't convert the hours into seconds, then the unit for energy will be watt-hour. In that case, the power multiplied by time, which is 100 times 2, will give you 200 watt-hour energy. Active and passive elements. There are two types of elements found in electric circuits: passive elements and active elements. An active element is capable of generating energy, while a passive element is not. Examples of passive elements are resistors, capacitors, and inductors. Typical active elements include generators, batteries, and operational amplifiers. In other words, the sources are basically the active elements in an electric circuit, and the loads are considered to be the passive elements. Now, the most important active elements are voltage or current sources that generally deliver power to the circuit. These sources, both the voltage or current, can be further classified into independent and dependent sources. Now, we know that all sources, whether it's a voltage source or a current source, are active elements. Now, these can be further classified into independent and dependent type. That is, voltage sources can be of two types: independent source or dependent source. Similarly, current source can be classified into two types: independent and dependent. In this slide, we will discuss the independent sources. And then in the next slide, we will discuss the dependent sources. Now, an ideal independent voltage source delivers to the circuit whatever current is necessary to maintain its terminal voltage. That is, for example, if you buy a battery which has a 5-volt potential across its terminal, it will always provide 5-volt potential difference irrespective of whatever current flows through the circuit. Similarly, an independent current source will always deliver the designated current to the circuit irrespective of whatever the voltage is across the source. Now, the symbol for independent voltage source is this one or this one. Whenever you have a circle and inside that a positive and a negative terminal, it means a independent voltage source. That is, the voltage or potential difference that it provides to the circuit does not depend on any other element. Another symbol for independent voltage source is this one. An independent current source is represented by this symbol. An ideal dependent source, as the name suggests, are those sources whose value is controlled by another element in the circuit, or whose value depends on the value of another element in the circuit. Dependent sources are usually designated by the diamond-shaped symbols. The voltage source, the dependent voltage source symbol is this one, and the dependent current source symbol is this one. There are four possible types of dependent sources: a voltage controlled voltage source, a current controlled voltage source, a voltage controlled current source, and a current controlled current source. These will become much more clear to you once we move on to the next chapter, where we will solve problems based on these different types of sources. Resistance. We know that when we apply a voltage or a potential difference across a wire or a circuit, then it results in the flow of charges or current. Now, the question remains, what determines the level of this current? For example, if a source applies a 5-volt potential difference across a circuit, then what will determine the level of current flowing through the circuit? The answer is resistance. Resistance is an opposition force to the flow of charges. That is, it opposes the motion of the charges. This opposition to the flow of charges to an electrical circuit is called resistance, has the units of ohms, and uses the Greek letter omega as its symbol. The circuit symbol for resistance is as shown in this figure. The opposition due to primary collision and friction between the free electrons and other electrons, ions, and atoms in the path of motion converts the supplied electrical energy into heat. This heat raises the temperature of the electrical component and the surrounding medium. The resistance of any material is due primarily to four factors: material, length, cross-sectional area, and temperature of the material. The first three elements are related by the following basic equation. That is, resistance is equal resistivity into length by area. Conductance. Conductance is inversely proportional to resistance of a material. By finding the reciprocal of the resistance of a material, we can have a measure of how well the material will conduct electricity. Conductance has the symbol G and its unit is S. In the next problem, we have been asked to determine the conductance of a 1 ohm, 50 kilo ohm and 10 mega ohm resistor. We have also been asked to deduce how the conductance level change with increase in resistance. So, as I have mentioned that G equals 1 by R, therefore, when R equals 1 ohm, G will be 1 by R 1s. When R equals 50 kilo ohm, G will be 0.02 into 10 to the power minus 3s. When R is 10 mega ohm, G will be 0.1 into 10 to the power minus 6s. So, by looking at the answers, we can say that as the resistance increases, the conductance of the material decreases. Thank you.